In this question, we need to find out two things. First is width of this transistor, and this transistor is PMOS transistor, and resistance R. So let's first find out the terminal voltage of the transistor. So as you can see in the circuit diagram, gate, this one is your gate terminal and this one is the drain terminal. So both gate and drain terminals are connected. So we can write Vg equal to Vd, and it is given as 1 volt. This one is source terminal. We can write it as Vs, and Vs is given as 1.8 volt. So now we can find out two voltages. First one is VGS. VGS we can write it as Vg minus Vs. It will be 1 minus 1.8. So it will be equal to minus 0.8, which is less than Vt. Vt is minus 0.5 of the transistor, which means this VGS is less than Vt of the transistor, which means PMOS transistor is in on condition. So now let's find out VDS. So we can write it as Vd minus Vs. So Vd minus Vs is 1 minus 1.8, which means it will be equal to minus 0.8 volt. Now let's find out VGS minus Vt. VGS we have already calculated, which is minus 0.8, and Vt is minus 0.5. So VGS minus Vt is minus 0.3 volt. So now as you can see, if you compare VGS and VGS minus Vt, so your VDS is less than VGS minus Vt. So for any PMOS transistor, when VGS is less than Vt and VDS is less than VGS minus Vt, transistor will be biased in saturation region. So now we can use the saturation current equation, and we can write it as half μpCox W by L into VGS minus Vt square. So now we can put the values of given parameters. μpCox is 100 into 10 to the power minus 6. W by L, W we need to calculate. L is given as 0.18 micrometer. VGS minus Vt is VGS minus Vt is minus 0.3 square, and the value of drain current is given to us, which is 180 microampere. So we can find out W here as 7.2 micrometer. So width of the PMOS transistor for given parameters is 7.2 micrometers. Now the current flowing across this PMOS transistor will be same as the current flowing across resistance. So we can write down IR, which means current across resistance is 180 microampere, and we can represent IR as potential difference across resistance divided by resistance itself, and thus VR across resistance R is equal to drain voltage of the transistor. So we can write Vd instead of VR. So R can be calculated as Vd divided by 180 microampere. So Vd is already given to us 1 volt divided by 180 microampere. So we can calculate R as approximately 5.56 kilo ohm.